Hello everyone and welcome. AI-assisted development is rapidly evolving. Earlier, AI tools mainly helped developers by suggesting code or answering questions. Today we have agentic AI systems that can go a step further. They can plan tasks, take actions, make code changes, and even create pull requests inside GitHub. This shift changes the role of developers. Instead of only writing code, developers now supervise, guide, review, and approve the work performed by AI agents. In this session, we'll understand what agentic AI is, how it differs from traditional AI assistants, how agents work using the Plan Act Evaluate lifecycle, and how GitHub helps control and govern agent activities. What is agentic AI? Most developers are familiar with AI assistants. An assistant responds to a prompt, provides suggestions, and then waits for the user to take action. For example, suggesting code, explaining an error, generating documentation. The assistant gives recommendations, but the developer still performs the actual work. Agentic AI is different. An AI agent can understand a goal, create a plan, perform actions, use tools, evaluate results, improve its work based on feedback. Instead of simply helping development, agents actively participate in development. Assistant versus agent. Let's understand the difference clearly. Assistant. An assistant responds to prompts, provides suggestions, requires manual execution, does not modify repositories directly. Example: you ask, how do I update this dependency safely? The assistant provides steps and recommendations. You perform the update yourself. Agent. An agent understands the goal, decides intermediate steps, uses available tools, creates branches and commits, opens pull requests, responds to feedback. Example: a security vulnerability is detected. The agent creates a new branch, updates package versions, commits the changes, opens a pull request, waits for validation and review. This is true agent behavior. Agent lifecycle Plan Act Evaluate. The heart of every agent system is a continuous loop. Plan Act Evaluate. And most importantly, this is not a one-time process. The cycle repeats until the desired outcome is achieved. Step 1: Plan. The agent first understands the goal and creates a plan. A good plan should answer: what is changing? Why is it changing? How will success be measured? What happens if something fails? In GitHub, plans are often visible through pull request descriptions, linked issues, checklists, project tasks. A visible plan makes the work easier to review and trust. Step 2: Act. Next, the agent executes the plan. Typical actions include creating a branch, updating files, committing code, opening a pull request, responding to review comments. The important point is that actions remain controlled within GitHub workflows instead of directly changing production code. Step 3: Evaluate. After acting, the agent evaluates the results. Evaluation uses objective signals such as build results, unit tests, CI/CD checks, security scans, code reviews, approval workflows. If everything passes, the work can move forward. If issues remain, the cycle starts again. The agent updates the plan, makes corrections, and re-evaluates the outcome. This continuous loop is what makes agentic systems reliable. GitHub as the system of record. For agentic workflows, GitHub becomes more than just a code repository. GitHub serves as the system of record. This means GitHub stores all development evidence including repositories, branches, commits, pull requests, workflow runs, reviews, discussions. Every action performed by an agent is visible and traceable. This provides transparency and accountability. GitHub as the control plane. GitHub also acts as the control plane. A control plane governs what agents can and cannot do. GitHub provides several controls. Pull requests. All changes are proposed before being merged. Required reviews. Human reviewers must approve important changes. Status checks. Builds, tests, and validations must pass. Code owners. Changes are automatically routed to the right experts. Branch protection and rule sets. Prevent unsafe merges and enforce company policies. Environments. Control access to secrets and deployments. Together, These controls ensure agent actions remain safe and supervised. Responsibilities and risks. Even when agents perform work, responsibility does not move from humans to AI. Humans remain accountable for defining tasks, setting permissions, reviewing changes, approving releases. The agent may perform the work, but people remain responsible for the outcome. Common risks. There are several common risks in agentic systems. Planless execution. Agents start making changes without a clear plan. Over-permissioned agents. Agents receive more access than required. Hidden reasoning. No explanation exists for why a decision was made. Blind trust. Teams assume that passing tests automatically means everything is correct. These risks can be reduced using pull requests, approvals, branch protection, and proper reviews. Importance of traceability. For every agent-generated change, organizations must maintain traceability. A minimum audit trail should include a clear goal, a documented plan, branches and commits, test results, review comments, final approval or rejection. Traceability helps teams understand what happened, why it happened, and who approved it. This becomes critical when troubleshooting issues in production. Using the contributor model. One of the best ways to evaluate agent-generated work is to treat it like any other contribution. Instead of asking, was this created by AI? Does it solve the problem? Is the scope appropriate? Did all checks pass? Were the right people involved? Does it follow organizational policies? This is called the contributor model. The same standards applied to human developers should be applied to agent-generated contributions. What good agent contributions look like? A high-quality agent contribution should be easy to understand, clearly planned, properly scoped, fully reviewable, supported by evidence, compliant with policies, traceable through audit logs and pull requests. When these conditions are met, teams can confidently use agentic systems while maintaining governance and security. Summary. Let's quickly recap. In this module, we learned that agentic AI goes beyond assistance and actively participates in software development. Agents differ from assistants because they can plan, act, and evaluate tasks. Agent workflows operate through a continuous plan-act-evaluate loop. GitHub acts as both a system of record and a control plane for agent activities. Human teams remain accountable for all outcomes. Pull requests, reviews, status checks, code owners, environments, and branch protection provide governance and control. Agent-generated work should be evaluated using the same contributor standards applied to human contributions. By combining AI agents with strong governance and human oversight, organizations can improve productivity while maintaining security, quality, and compliance. Thank you, and let's continue exploring how agentic AI can transform modern software development workflows.